9th Standard ICSE Chemistry, Chapter 2, Part C, Energy Changes in Chemical Reactions. Whenever a chemical reaction happens, there are some energy changes. Energy is either absorbed or released, or both. This energy can be in the form of heat, light, sound, and electricity. Now, this is the definition of chemical energy, which is stored in all substances. For example, when we burn fuel, we are using the chemical energy stored in it to be converted into heat and light energy. So during chemical reaction, the breaking up of chemical bonds absorbs energy, and simultaneously, formation of the new bonds will release energy. Depending on which of these two is greater, the reaction can be exothermic or endothermic. If the energy released is more, then overall there is a release in energy. That is called an exothermic reaction. They lead to an increase in temperature of the surroundings. Examples have to be learned here. Initially we have to heat it for the reaction to take place, but the heat released is far more than the heat we have to give in the beginning. Similarly, burning of methane is exothermic. In fact, burning of any fuel is exothermic. Even addition of quicklime to water to form slake lime. And by the way, slake lime dissolved in water is called lime water. That's exothermic. So you will notice that the water starts boiling and a hissing sound is produced, and the glass becomes hot. Even formation of water is exothermic, which is so ironic. Formation of ammonia, this reaction is very important. It is a part of the Haber's process, which we'll study in future chapters. It's a reversible reaction, exothermic. Initially heat is required. There are 4 conditions to remember. Temperature should be 450 to 500 degrees Celsius. Pressure should be above 200 atmospheres. By the way, the pressure at sea level, normal air pressure on a body, is 1 atmosphere. The catalyst used is finely divided iron, and the promoter is molybdenum. Write it. Promoter is a chemical which increases the efficiency of a catalyst. And the catalyst here increases the rate of reaction. There are some negative catalysts also which decrease the rate of reaction. For example, alcohol. And no, I'm not talking about it decreasing your rate of or speed of driving a car. I'm talking about chemical reactions. Another example, all neutralization reactions are exothermic, but acid plus base gives salt plus water only. Even the respiration reactions and digestion reactions happening in a body are exothermic. More examples again here. In endothermic, overall the heat released is less than the heat absorbed. So net result is heat is absorbed. Endothermic, it results in decrease in surrounding temperature. Examples are given. Carbon plus sulfur gives carbon disulfide, endothermic. Nitrogen plus oxygen gives nitric oxide, also called nitrogen monoxide, at 3000 degrees Celsius. You have to mention the temperature. Calcium carbonate has to be heated to decompose it. Next, photochemical reaction takes help of light energy. Example, photosynthesis. Another example is decomposition of silver nitrate into silver, nitrogen dioxide, and oxygen. This reaction is repeated. Electrochemical reaction takes place with the absorption of electrical energy. Now, this is an ionic reaction where fused KCl, fused means molten, no water here. When electricity is passed through it, splits or dissociates into potassium and chloride ions, and hence it becomes a good conductor of electricity because of ions. Water splits to give hydrogen and oxygen in the ratio 2:1. Now note, pure water is a poor conductor of electricity, so we have to add a few drops of sulfuric acid. So we have to mention acidulated yellow water in the reaction.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.